So we've got a small room, and I'm super informal. So I'm going to walk around because that's what I do. But also feel free. I mean, we've got time for questions at the end, but if stuff comes up in the middle, I feel like instead of me talking at you for an hour, that we can totally interact. So again, my name's Christine. I'm really happy to be here. There's a couple of different projects that I'm going to talk about, most that have to do with stormwater, and a lot of the work that we do at the Watershed Center is basically protecting the bay. That is, I think it's that way, but I can't tell from where we are in this room. So, woo! Okay, I'm going to do this. There we go. Okay. So the Watershed Center, we advocate for clean water in Grand Traverse Bay, and we act to protect and preserve its watershed. So there's a few ways that we do that. We do monitoring work. So in order for us to know what we need to do in order to help protect the bay, we need to know what our problems are. So we do a lot of stream monitoring. This is a picture of Kids Creek here in Traverse City, where we're looking for road salts that might be getting in, and we think chloride might be an issue. So we're doing some monitoring to see so that if it is an issue, we can try to fix it. We plan, so we hold 3 watershed protection plans. Watershed protection plans, if you're not familiar, are state and federally approved plans that basically outline what your watershed looks like, what its threats are, and then you have a whole table full of stuff that you need to do in order to protect that watershed. So I'll go into what our watershed is, but a lot of the work that we do is implementing the plans that we have for our various watersheds. We do improvement projects. So this is a picture also of Kids Creek over by Munson Medical Center, where a few years ago they wanted to build a cancer center, but there was an underground culverted creek in the way. And so to build that cancer center, we helped them daylight the creek. So this is before the water was flowing through that creek, but we do a lot of stream restoration projects and things like that. We advocate. The picture that you're seeing on the left is a site plan for a campground that's being proposed up in Northport. So this is a good example of something that they want to do some development in the wetlands, and so we're trying to work with them to move their campsites and things out of those wetlands. So we do a lot of advocacy work, either working specifically with individuals on projects. We also do advocacy work with our local units of government and trying to have policies and procedures and ordinances that help protect water quality. We are a resource. So folks can call us and say, hey, my neighbor is out cutting all of the vegetation on their waterfront property. Are they allowed to do that? It's usually about your neighbor. It's usually somebody calling, telling on their neighbor. Or I see a car wash that has, water that's running into the storm drain. Is that allowed? So we try to be a resource for folks, either to connect them to the proper enforcement agency or answer the questions that they have or provide information so that folks can make good decisions on a daily basis for water quality. And then lastly, we try to engage people in our work. So one of the main ways that we do this is through a volunteer stream monitoring program that we have, where folks go out into the stream and they look for bugs and they help figure out the quality of the water in the stream. So it's great to engage folks in that, but it also helps because that data gets into a statewide database, and the state can look at it and see if there's trends over time. Say it used to be really good quality and now it's deteriorating. Maybe the state will go out and do a more thorough assessment and try to figure out what's going on. So that's the basis of what we do. Here's where we do it. So to make sure we're all on the same page, a watershed is an area of land that surrounds a water body. So all of the water that falls on that land is going to flow into a common water body. So when we're talking about the Grand Traverse Bay watershed, we're actually talking about the land that surrounds it. Most people think that because our name has Grand Traverse Bay in it, that's where we do our work, but 99% of our work is actually on the land. So the watershed itself is almost 1,000 square miles. There's the bay has 132 miles of shoreline. It has a really deep point over on West Bay that's almost 600 feet. About 220 billion gallons of water go into it every year from its tributaries, and it covers 55 jurisdictions, so counties, townships, cities, and municipalities, which means there's a lot of red tape of trying to get things on a larger scale accomplished when you're dealing with a lot of different jurisdictions. So that's the Grand Traverse Bay watershed. What I'm going to talk today about is the Elk River Chain of Lakes. So the Elk River Chain of Lakes gives about 60% of the water that goes into Grand Traverse Bay comes from the chain of lakes. So if you're not familiar with this area, it's a super cool series of interconnected lakes and streams that covers about 500 square miles. There are 14 lakes and a bunch of streams that come into it, and it basically ends up outletting into the bay over by Elk Rapids. So it's a fairly large watershed, and it covers 36 jurisdictions. So a large number of those jurisdictions are covered there. So let's all get on the same page. A healthy watershed is beneficial both to have a healthy ecosystem, but also to have, there's a lot of community benefits for a healthy watershed as well. So as many things as I could actually fit on the slide I threw up here, but there's a lot of benefits to having a healthy ecosystem and recognizing that everything is also connected. So if there's one aspect of your ecosystem that, like, let's say loss of vegetation, it's going to have an effect on a lot of those other benefits as well. So recognizing that connectedness between an ecosystem and the watershed is super important when we're looking at, you know, the impacts of human-caused sources and things like that. There's sort of a trickling effect where it will spread out through that whole watershed. So lots of things that are familiar, you know, air quality, there's food and habitat for wildlife, there's recreation for folks, there's just scenic beauty, cultural significance, a lot of things that make up a healthy watershed. Some of the most significant threats that we have to water quality, if you look at this, you'll notice that every single one of these are human caused, right? So shoreline hardening, wetland loss, invasive species coming in, contaminants in our groundwater or drinking water, stormwater runoff, all of these things are human-caused threats to water quality.
Is shoreline hardening, is that like putting in large parking structures, buildings, and those type of things where you harden up the shoreline, that, or what is it?
When I'm talking about shoreline hardening, I mean most specifically like a parcel that's on a water body that has like a seawall. So actually, you know, or big riprap without any plants, things like that. So that natural shoreline, and actually I will talk about natural shorelines in a second. So that's just that sort of hardening that land-water interface. So a couple of reasons that these threats are really important. One, we're going to talk about vegetation and tree canopy. So there's a list of ecosystem services that those provide. And if you look at the yellow, my pointer still works. If you look at this yellow, so this is turf grass right here. So that's how shallow the root system is on turf grass. If you look at some of the other native plants that come out here to the left and right, and you look at those deep roots are going to help hold your soil together. They're going to help absorb nutrients and pollutants and things like that. They also help these plants be more sustainable in the type of climate that we have and withstanding drought. So when we talk about the importance of vegetation, we really mean more than just turf grass. We're talking sort of leafy things or grasses that have large roots, because those are the ones that can provide your most ecosystem services. And tree cover, I don't think it's a surprise to anybody that tree cover has been reducing and continues to be reduced. So that threat is still there. Oh, look, this works now. Okay, I went the wrong way though. So in terms of natural shorelines and nearshore areas, so this is what I'm talking about, this natural land-water interface here that is a huge breeding ground in the Great Lakes for every single fish species that we have. There are plants and there are trees that overhang it, that shade the water, and all of these things that happen on natural shorelines that are good for our ecosystem benefits. When you harden that surface, you significantly change that land-water interface. You are taking the energy that comes from the lake and you're actually pushing that down into the ground, so you will get scouring, you'll have very little habitat there. If you have a hardened shoreline that is not hardened on either side, you'll get scouring around those sides. So often what you'll see is one person on a lake will put in a seawall, and then the next person will put in a seawall because that has now been sort of redirected towards them, and then it kind of moves itself out. So recognizing that, in particular, Great Lakes water levels rise and fall, and as naturally, lately they've been doing it in more extreme levels, but they still naturally rise and fall. So when we have high water level years, everybody wants to harden the shorelines to help protect the infrastructure that is landward. And when we have low water years, everybody likes to groom the beaches so there aren't any of those pesky plants and things like that in the way. So either way, we're really changing what that area between the land and the water looks like, which is having a huge impact on our ecosystem. Wetlands are amazing. They're one of the most productive places that we have on Earth. They have every ecosystem benefit you could possibly think of. They harbor so many animals and plants and fish and those sorts of things. But wetlands are one of the things that have been most significantly reduced. In Grand Traverse Bay in particular, over 50% of our pre-development wetlands have now disappeared. And most of that is due to sort of fragmenting those wetlands as you look along the shoreline. Most of that stuff is due to development. So that would be, even if it's a small fill of a wetland, you know, death by 1,000 cuts, right? So you do it here and you do it there, and then all of a sudden the wetland itself is changed. It no longer connects. It doesn't function the way that it's supposed to, and then you lose all of those ecosystem services. So wetland loss is definitely one of the biggest threats that we have, I would say in the Great Lakes area in particular. Stormwater. So great day to talk about stormwater. If anybody's been outside, you can even watch this stuff. I watched a couple swirling tornadoes down some storm drains too. And this has been an issue in Traverse City in particular in the last few years as we get more intense, more frequent rainfalls. So the more we harden our surfaces, the less the water is able to infiltrate into the ground. And particularly in urban areas, you have lots of impervious surfaces, and then that is all directed to some sort of stormwater system. And those stormwater systems were made 80 years ago and are undersized, under-maintained, and so we tend to get a lot of flooding that happens when those. So these are pictures from a couple of years ago. This one is actually a project that we worked on to try to alleviate this, and this is a boat launch out by Clinch Park. So the more impervious surfaces we have, the more stormwater issues we have. The more stormwater we have, the more likely that stormwater is going to pick up pollutants and trash and things on the road. And then we don't have, in our watershed at least, all of the stormwater systems outlet directly to another water body, whether it's a lake, river that eventually gets out into the bay or directly into the bay. So that direct connection is basically taking everything that's falling on that land and channeling it and shooting it out of pipe. Okay, I mentioned the watershed plans that we have. So the Elk River Chain of Lakes has a watershed protection plan right now. It's sitting with the state for approval, but we're still implementing it. The Elk River Chain of Lakes, we call it ERCL. So the ERCL watershed is one of the most pristine watersheds, definitely in our area, but most likely in our region. Lots of economic benefits, lots of recreational benefits. That difference between the streams and the lakes and the wetlands that they have, there's just really diverse. But again, human-driven actions really threaten to impair these. The top 5 in the Chain of Lakes are lakeshore development. So again, that building right up next to the shore, hardening your shoreline, having a lawn directly all the way down to the shoreline. Impervious surface and stormwater runoff. Invasive species, so this is both aquatic and terrestrial. So things that are in the water, like zebra mussels, or things that are on the land like Phragmites. So there's lots of different types of invasive species. Road stream crossings, so this is where a road goes over a stream. There's any number of issues with those. You can have undersized culverts so that there's no passage for fish to get through. There's generally a lot of erosion that's happening on the sides of road stream crossings, so a lot of sediment getting into the area. In the Chain of Lakes in particular, one of the largest impairments that it has is sediment. It's already a sediment-driven system, but getting a lot of sediment from their road stream crossings in particular is one of the reasons why there's some impairments on that watershed. And then failing septic systems. I don't think anybody hasn't heard that septic systems are an issue in our state, and in particular along waterfront property where you may have an old or undersized system from, let's say, an old cottage that was then updated, but the septic system is still the old septic system, and that sort of direct connection to the water is pretty close and pretty frequent. Okay. When we looked at the watershed plan, there's lots of partners, lots of people doing things, lots of things that are happening. But in particular, what's really evident in the chain of lakes is that connection, how we don't, I don't want to say we've solved all of the like point source problems, like, you know, that pipe is doing that issue, right? We've addressed a lot of those. We haven't solved all of them, but we've addressed all of those. The issues that we're facing now are more of the like runoff issues, the larger scale things happening upstream, sediment coming in upstream that's affecting downstream. There are these watershed-wide issues that are impacting, that are not as simple to solve, right? You can't just shut off a pipe and solve your problem. There are these larger, what are called non-point source, so things that don't have a specific point. What we recognized in this watershed in particular is the need to address some of those super complex problems, and the fact that lake associations who are on the downstream end, like Elk Lake and Skagamog Lake, the ones that are down there are seeing impacts from what's happening upstream from them. And they want to be able to work together to try to address those things so that it's beneficial for both. So we started this initiative that's looking at a collaborative approach to try to address some of those more complex problems. The way we started this was basically by asking everybody we could find in the watershed, saying, what are some really high urgency, high impact challenges that water quality is facing? And we just wrote them down. We had a ton of them, right? We just kind of wrote them down and said, what are all of these issues that we have? And then we looked at each one of those issues and we sort of said, okay, in order for these issues to actually be addressed, and especially if we're going to do this collaboratively, we need the resources to do it, we need some leadership, we need to know that this is actually going to be something that we're able to prioritize and focus on. So we looked at, you know, the processes that were needed to do it, we looked at the resources that were available, and we prioritized that super long list basically down into two things: septic system management and shoreline protection. So these were identified as issues that need to be addressed now, and that we have the resources and the interest and the leadership that's going to move these things forward. What we did is we took each one of those then and we made an action plan, and we said, okay, what's our goal? What are the tasks we want to accomplish? Who are the people that are going to be involved? What's our timeline? What resources do we need? And we set up the framework for basically a committee of folks to sit around and try to help solve some of these problems. For septic system management, the goal is to ensure that all septic systems function in a way that protects public health and water quality. There are local ways of doing that in terms of local ordinances like time of transfer or point of sale ordinances. So some of that is working with our local jurisdictions and educating them and trying to get some of those things passed. Some of this is working at the state level and trying to get a statewide septic code, since we are the only state in the nation that does not have one, trying to advocate for having one. Something's better than nothing, right? And then some of this is homeowner education, trying to make sure that we're connecting with people so that they understand. And then lastly, monitoring and making connections with folks. So, you know, all of a sudden we see a giant plant bed on a nearshore area that was not there before. Like, to be able to identify that and do some source tracking and figure out that, you know, hey, this may be coming from septic system in this area and we need to do something about it. So also having the data to make that clear connection for folks to understand what's happening on their land is impacting the water. In terms of shoreline protection, there's really two main things. One is always education, educating our landowners, best practices, things you should and should not do. And then the other one is looking at our local policies, ordinances and things, and saying, do we have protective measures in place? Do we have riparian buffers, so things that require plants to be planted on that nearshore area? Do we have water's edge setbacks, so we're requiring buildings to be set back 50 feet from the water to allow some of that natural shoreline stuff to happen and higher water levels not to flood your property and things like that? Do we have those things in place? Here's where we sit with these things right now. The septic system management, there's been some brochures that have been developed. There was a survey that was done. Milton Township in Antrim County has I believe it's a time of transfer ordinance, and they've had it for about a decade. And they went and they asked the property owners who went through that process, and they said, hey, was this valuable to you? What did you think about it? Were there barriers? Blah, blah, blah. And basically what they found is most folks were appreciative of this. So they found some things. So before you buy your house, you have to have your septic system inspected. And so people who are potential buyers, there were some things that needed to be fixed before they actually, bought the home. And so they were appreciative that those things were found. We didn't ask the other way around, people who sold the house, what that was like from their perspective, and recognizing that this is sort of just a very small point in time, but looking at something that is trying to, it's not solving all of the problems, but it is one of the tools that we have. And knowing that folks who have gone through that process thought that it was a decent process to go through and understood why and appreciated it was helpful. And then now there's a presentation that's been put together that folks are going around to some of the local jurisdictions. One is just sort of what is the problem and what are we doing, what are we dealing with? And the other one is what are some of the potential solutions? So again, there is no silver bullet, in my opinion, as to like this is the right answer to save septic system issues. But there is at least a dozen tools that we have, and just implementing one of those is going to get us farther than we are now. In terms of the shoreline protection group, from the education perspective, there's a riparian handbook that the Elk-Skagamog Lakes Association has given to all of their riparian property owners when they move in for 20 years. We want to look at this and actually expand so all lake associations have this. So we're going to look at updating this. It's interesting to see if you look back on a 20-year-old document what we saw and thought was important then and then what we're dealing with now, and recognizing like there's huge sections that are missing because they weren't issues 20 years ago. So to be able to update that and have an actual handbook and that it's consistent. So if you buy a house on 6 Mile Lake, you're getting the same handbook that you would if you buy a house on Torch Lake. And that messaging is consistent, and so the more people hear that, the more that it might be likely that they might do something. Another aspect of this is we chose about 5 priority communities in the chain of lakes, and we sat down with their staff and elected officials, and we said, hey, what are you guys doing for water quality? Do you have barriers? Or what are you interested in doing? What other issues are you dealing with as a small community, small rural community? Here are some resources we have that we might be able to help you with. Would you be interested in a time of transfer ordinance? So we had this conversation of sort of, what are you guys dealing with as a super small community dealing with all kinds of other issues from an environmental perspective? And here's the tools that we have to maybe help that. Are there any ways to kind of, work together on these things? So those conversations were incredibly helpful, and we're sort of working through those interviews. But what we also did is look at their actual ordinances and said, do they have a riparian buffer ordinance? Do they have provisions in their zoning ordinance that requires when they do a site plan review that they have to have they have to go through and update all of the things to meet their current ordinances, things like that. I don't want to get into the details, but the 2 things that I'll say that we did find interesting were there seemed to be general categories of things that everybody had or nobody had, and then kind of a smattering. So each of those 5 communities we looked at did have a riparian buffer ordinance of some sort, right? Nobody had a tree protection ordinance. So we've identified places that we need to strengthen because we know everybody has one, but they may not all be great. And then we've identified huge gaps. And so now we can sort of start trying to address those and going into those communities and talking about that. So I'm going to shift. Look at my time. I'm going to shift and talk about our work in particular and some of the stormwater efforts that we have. Sediments and nutrients are the biggest threats to Grand Traverse Bay watershed, which is why a lot of our on-the-ground efforts focus on the stormwater aspect. So we're trying to keep stormwater out. We're trying to keep pollutants and the associated nutrients and things that are with those out of the bay. And so when we talk about reduction, that's what I mean, basically trying to keep it out of the watershed. We've done several projects. A lot of these projects, we're also involved in the local beach monitoring. So every Wednesday in the summer, we have folks that go out and look for, basically for E. coli levels. And by checking for E. coli levels, we know that there are harmful bacteria that might affect beachgoers. So there's that whole beach closing system. You guys know what I'm talking about with this stuff, right? Everybody's seen it. So we do that program here, and it's actually facilitated, when I talked about the monitoring work that we do, it's actually facilitated a lot of the stormwater work that we've been able to do. So in Northport, Suttons Bay, and Bryant Park, those were all areas where E. coli levels were high for a significant amount of time over a few years. And so we knew that there were stormwater. All public beaches are where stormwater outlets are, because that's the public place that you can have them. So anytime there's a rain event, you're gonna get a flush of, you know, everything that's in your storm drain going out into a public beach. So tip, don't swim directly after a rain event. So we were able to notice that we were getting a lot of closures, and so we were able to do some projects in these communities that actually helped reduce the amount of beach closures that we have, because we're now treating that stormwater before it gets out into the bay. Specifically, I'm going to talk about the one we're doing right now in the village of Elk Rapids. We are using green infrastructure techniques. And so green infrastructure basically just mimics what nature would do. You're trying to channel stormwater into a certain area, get it to slow down and infiltrate into the soil. There's a lot of what I'll call gray infrastructure things that try to treat stormwater, but there's nothing better than soil to actually treat stormwater. It gets out the largest numbers of pollutants and nutrients and oils and greases and bacteria, where you would have to have super expensive filters and all kinds of things in order to do that with some type of gray infrastructure. So anytime that we're able to actually take stormwater and put it so that it infiltrates into the ground, that's the biggest benefit we can find. There are two ways that we did this in Elk Rapids. One is through rain gardens. So rain gardens are basically just a shallow depression that has a lot of plants in it. So you're actively directing your stormwater to that rain garden. So the picture that we have here is one of the things that we did in Suttons Bay. We put in 18 rain gardens. They were roadside rain gardens. Several of those we took out like a parking spot. So if you want to think about a street, and then every 10 parking spots, there's a rain garden. And you would actually direct your stormwater. You can curb it off and direct your stormwater into that rain garden. And the water just basically fills up. It helps reduce flooding. It acts as storage, so more stormwater can go in there, and it slows down and infiltrates over time, versus that water directly running into your stormwater system and kind of gushing out at the end of the pipe. They're all planted with native vegetation. Again, that whole concept of making sure you have deep-rooted plants that are local and used to the climate conditions that you have. The other thing we did was install infiltration trenches. So these are huge, like you can stand inside of them, but they basically go underground. So as the water goes through your actual normal stormwater system, as the water goes into your catch basin, it gets slowed down and the sediment gets filtered out, and then it goes into these giant perforated pipes that basically have soil on the bottom. So it allows them to go into these perforated pipes. They generally sort of flow one to the other. You usually kind of line them up and the water flows. The more water you get, the more pipes get filled up, but it also has that huge space too to just act as storage capacity as well. So you don't see these, they're usually under streets. You don't even know that they're there, but you're taking that water that would go into the stormwater system normally, putting it underground and letting it infiltrate into the soil. So the work that we've done, the issues that we had, same thing that we talked about, stormwater inputs in the bay, contaminants coming into the water. Right here is their public beach, and you can see this is the Elk River that comes out. You can see all their stormwater outlets that go into the river, and then there's a stormwater outlet right here. So folks who are sitting here along this beach are getting everything that's coming out from all of their stormwater outlets every time that it rains. So we did a couple of projects. One was at the marina. So this before picture, this is just a big grassy area. It was flooded all of the time. There were curb cuts to try to allow the water to get in there, but the grass was sort of like filling them in, so there's flooding all the time. The people who mowed the lawn like just stopped mowing it for a while because it was too wet. Just this big sort of nasty area, and we didn't have to do much to this spot to turn it into basically into a bioswale. So we took that entire section, we excavated it out, we put some good soil in there, we threw a bunch of plants, and we're good. The thing about this area is you can see how close it is to the water. Right now we have a really high water table. This entire marina complex is fill, so it's not natural. So there's some issues at this site. And we're getting flooding. You can see this. We're getting flooding a little bit more than we would like to. We just installed this last fall, so we have yet to see the plants really grow in and establish, and the water level is now going down, so we hope that this is going to do a lot better. In another section of the marina, it was just sort of a landscaped, pretty little landscaped area at the edge of this whole parking area. And we took that and we turned it into a rain garden. So the rain garden now, there is, when we say pre-treatment before it goes in, it's basically getting out all of the sediments and things before it goes into the rain garden. So all of the stormwater that comes off of that parking lot is now directed into that rain garden. And again, plants and stuff here are pretty little. There's an overflow structure that goes right out into the water. One of the super cool things about this that I'm really excited about, we're doing a monitoring project here. So we're looking at what is in the stormwater before it enters the rain garden, and then what's in the stormwater after it infiltrates. So we can look at, like, you know, what's our phosphorus levels, what's our nitrogen levels, how many suspended solids do we have, and then after it's infiltrated and it goes into the outlet, what are the same things? And we can actually measure, instead of estimating, instead of like assuming, we can actually measure what this is going to be. And I checked these samples. There's two of these things. So this is the one that collects inlet, and this is collects outlet water. And just holding them up, like there's so much sediment and stuff that you can just see in the one before it comes into the rain garden. The one coming out looks a lot cleaner. So I'm super excited we did this. Last year we took a few samples, and this year we'll do some more. So I'm really excited to see, like, prove that rain gardens really are, and in this site in particular, how much they're getting out from each type of pollutant that would be going in. We did some more rain gardens along River Street. So this is sort of the main street downtown that goes, it's actually right parallel to the beach that I mentioned. These were nice little landscaped grassy islands. Nothing wrong with them, but we wanted to actually make them function to help reduce stormwater as well. So we took each one of those spots, we excavated out, and we planted a bunch of plants. These larger trees were transplanted closer to the river, so the village was able to take those larger trees and transplant them. And then the smaller ones were taken by the company that was doing the project to be used for other landscaping stuff and other things that they're doing. So we were able to save all of the plants and things that were in there, except for things like these large trees. We had several dead or invasive trees that the village wanted to get rid of anyways, and actually some that were not part of our project, but since we were coming in there and cutting them down, we were able to kind of do economy of scale and help them with those too. So we had a lot of folks who were kind of wary about us getting rid of their pretty looking plants and making it look kind of like this. But again, plants grow over time, and they'll come in next year, and in 3 years you won't even be able to tell that we did a project there. Lots of stormwater and stuff that we did. I'm gonna skip that. Okay, the last one, this is a project that we're working on right now. And again, the Cedar Street storm drain is 80% of all of the stormwater in Elk Rapids goes through that storm drain system. And we're gonna be able to treat all of it through the things that we're doing, the projects that we're doing. One is an infiltration trench, so that big, large orange thing that we talked about that's gonna go in. As the village, they are tearing up their street and they're replacing everything underneath it anyways, and so we're gonna throw an infiltration trench in under there. So the timing of that one worked out really well. And then as you sort of go up the pipe, if you will, at some of the intersections and places where there's either public property or private property where folks are willing to do this, we're gonna install either rain gardens or rock gardens, which are the same thing, just no plants. So they function the same way, they just don't have the plants that are gonna take up that material. And one of the things as we work in different communities on these different types of stormwater projects is that each community really needs to decide what's right for them. So Traverse City in particular does not want anything that has green leaves on it. They do not want to have to maintain green leafy things. They would much rather put in infiltration trench where they can take their vac truck that's already out there doing the catch basins and do the infiltration trench at the same time. Sutton's Bay, we did 18 rain gardens there. We got a volunteer group who goes out and weeds them, and the school has one, and a bunch of people have sort of adopted those rain gardens to help the village maintain those. So as we work in these communities and recognizing sort of when we were talking about when we were asking for barriers and those kinds of things, none of this stuff really should ever be a burden to the community that we're actually trying to help. It's a cost savings, it looks really pretty, it's a different type of maintenance, but it still requires maintenance. So making sure that each community is really on board and understands kind of what goes into that before those projects are decided. So that is what I have. How am I for time? I'm okay for time. Okay.
In the rock infiltration beds, are you putting in a specific catch basin in there that they can come set? As you said, you use the vacuum trucks, they come in and can clean the sediment out that it traps and that before it goes out? Or are you just using a geotextile base or something underneath the rock to slow it down and allow it to permeate into the soil?
So we would do the same thing like